that the devices that we are using on these aircraft are the simplest technological devices in the world today. There is nothing simpler. We are dealing with an empty, hollow tube with a mirror at one end. That's it. But you have to know how to shape the tube, how to tune it, and how to use it. Now let's see it all in the real world. Greetings and welcome to this overview presentation on primary energy weather engineering. My name is Trevor James Constable, and I am the engineer who designed and carried out all the weather engineering and control sequences that you are going to see on this tape. Time limitations automatically preclude my giving you any kind of comprehensive theory on how all this is done. Suffice it to say that it is achieved by manipulating the ether. Controversies about the ether have been raging for thousands of years, and they're probably going to go right on. What's important to us is that what has been learned in the past 20 years by my group about technically accessing the ether should be put to work in the here now, in conquering some of the Earth's intractable ecological problems. Let's leave the academicians and the theoreticians to their arguments. You come with me now to the North Pacific, on board a large ocean-going vessel of the United States Merchant Marine. And out there, we'll raise rain from nothing until the point where we have rain on the camera lens. Then we'll review for you Operation Pincer 2, which brought Los Angeles its wettest July in 100 years, an operation notified and filed in advance by us with the federal government. Then we'll let you see what 30,000 square kilometers of unforecast rain looks like in Singapore in the depth of the dry season. And finally, you'll get an eye-opening view into what these methods are capable of doing in countering smog in the worst smog region on Earth at the worst time of the year.
For 20 years in this work, my credo has been a simple one, and it has been followed inflexibly. Only results count. Only results count. That's what underlies what you're going to see now. Let's get at it.
The SS Maui is a large Matson container ship with 30,000 horsepower and a speed of 22 knots.
These weather guns on her flying bridge are essentially juxtaposed geometric forms of various kinds, mainly cylinders and cones. These are so designed that they will interact with the ether, and through this interaction produce changes in the air itself. Some of them are now no larger than the human hand. In this experiment, we arrange this device, the Black Widow, directly ahead of the vessel, and using vessel velocity, we begin to inject a reverse flow into an etheric flow, that is a primary flow, coming out of the west. The vessel is presently heading due west. You will watch carefully in this time-lapse tape. You will see that as the primary force is dammed up to the west of us, the atmosphere begins to bunch up as this accretion of force translates itself into the atmosphere itself. Step by step, with the aid of time-lapse, we see a sudden and increasingly massive blockage develop to the further westward progress of the primary force. The damming of this massive regional flow of primary force shows itself as a steadily densening dark line across the horizon. The atmosphere is now responding to the local damming of the etheric force. It is being backed up. It is something like an undertow at the beach. We are doing this with the Maui and her primary energy translator. Denser and denser it gets. The ether has properties of elasticity, and it will only tolerate so much compression before it overwhelms the dam as it just did. So let us watch the accretion process again. The flow from the vessel goes back into the westerly flow, head on, dams it up. The atmosphere responds by concentrating, as you see here. The ether is elastic, and it will only tolerate so much compression before, like a block of rubber, it springs back. There it goes. Now it's expanding past us. The very fact that with our speeding translator aboard the Maui, we were able to produce this temporary local damming has resulted in effects that have recoiled many miles back over the horizon. These will in due course result in rain. Already there, just to the left of the jackstaff, you can see some showers falling. But this is only the beginning of a profound regional change. Everything in primary energy weather engineering depends upon the normal concepts of potential being reversed. Etheric energy flows from low potential to high. Therefore, Your entire thinking must be changed if you are to do this work or to understand it fully. Now we are seeing some of the further consequences of putting our speeding translator into the primary continuum in the way that we did. After an hour, we have a very complex change right there on the windshield. An hour and 6 minutes and you have rain. You've seen the whole process. This in about 68 minutes to this. That first sequence dealt with the west to east primary current common to temperate latitudes. This is in the tropics, heading east out of Honolulu for California. In these latitudes there is an east to west etheric flow, which we are now damming in the same way as we did previously, with an emission from the specially designed translator aboard the speeding Maui. As the ether builds up its potential, water vapor automatically accretes, a gross meteorological response to the etheric engineering. This builds to what is known in etheric engineering as the discharge point, or lumination, whereupon rain results, as you see here. This sequence has been repeated hundreds of times. It is not an accident. We have taken you in 40 minutes from a perfectly normal tropical day like this, which we began engineering. You watched, you saw it. You finished up with regional rain. It is not metaphysics. It's as real as a punch in the nose. By the end of 1988, sequences like those last two you have seen were no longer being videotaped. We had passed the point where they had any further value for us. They stand as historical and objective evidence of what can be done to raise rain in dealing with the main terrestrial flows of ether. We had passed by the end of 1988 to laying down long lines of rain within high-pressure cells. These squall lines were usually remote from the vessel. They didn't come right onto the porthole like those sequences you've just seen, and they are considerably more difficult to document for presentation in something like this. However, radar is of service here, and I'm going to show you some radar shots that were made at the end of November 1988 aboard the Maui in a 1029 millibar high-pressure system. Here is the official U.S. Navy surface weather map for the 27th of November 1988. 4 a.m. local time, 1200 Greenwich time. There is the Maui, the red ship. As you can see, she is near the center of a 1029 millibar high, right there, while voyaging from Hawaii to Oakland, following this irregular course. 1029 millibars at the center of this high, and the atmospheric circulation around it is clockwise, like that. And it is 12:30 p.m. where we are right here. Let's go out on deck and take a look at the barometer as we go. There it is, 1028 millibars. Out on deck, classic Eastern Pacific high. Nothing irregular here. Typical Eastern Pacific high pressure weather. Until we come around onto the starboard side. Here we find an anomalous shower line
Going down our starboard side in the general direction of the center of that high. And as we pan across that shower line, coming up towards the bow, we find that this shower activity is breaking out, as it were, in a specific geometric relationship to the vessel and its course. This activity is not happenstance, it is engineering. And this accretion will stay there for hours, moving across the surface of the sea within this high-pressure cell in exactly the same distance and angular orientation to the vessel. This anomalous rain line is being generated and laid down just like a smoke screen. And observation on 3-centimeter radar shows that at the present time it is more than 12 miles in length. Changing the orientation of the translators can send this accretion, or one like it, down the opposite side of the vessel. We'll show you that on radar this same evening. Here is the screen of the Maui's collision avoidance system at 9:11 p.m. that night. This is a still photograph of that same display so that we may clarify its characteristics for you more readily. The 27th of November, 1988. The Maui is at the center of the screen. Her line of advance is 073 degrees on a course from Honolulu to Oakland. The gradations in the upper right corner of our picture are the gyro ring of the collision avoidance system. Each dark and each light segment of the heading flasher represents 2 nautical miles of over-the-ocean distance, and this allows you to readily estimate the extent of this enormous rain mass lying to the north of our course. This, however, is a digitalized presentation and is not completely accurate as to its extent, everything below a certain minimum value having been dropped out. Therefore, let us increase our sense of realism by going directly to the original radar from which this picture was digitally composed. 4 miles between each of those rotating rings. The scope itself is 48 miles in diameter. From this you can see very readily, an original radar display, that this rainy system is over 30 miles long, and it is in a 1030 millibar high. The maritime methods that you have just seen in capsule form laid the basis for parallel work ashore from fixed bases. And this work has gone on since about 1968. The major goal that we pursued in California was the statistical barrier represented by the rainlessness of Los Angeles in July. We mounted a series of projects beginning in 1976 that culminated in 1986 with the smashing of that statistical barrier. A major triumph for weather engineering, and one that was fully documented. Federal law requires that you file this kind of report before you begin any weather modification operations. In the filing for Pincer 2, we laid out what we were going to do and how we were going to do it. For orientation purposes, here is a map of Southern California. Los Angeles right there, the red chip. There is the Southern California coast to Mexico to Baja California. Over here is the Gulf of California, the Colorado River running up to Arizona and Nevada. The Mexican border,
The Mexican border again, Arizona, Sonora, Baja California, Southern California itself, Arizona and Nevada on this side. This is the official map filed with NOAA in Rockville, Maryland before Pincer 2 commenced. The essence of the engineering is that there are two flows of primary force involved. Now this is not wind we're speaking of here, but primary force or ether. One flow comes from west to east like this across this area year-round. There is a seasonal flow that comes from south to north in the spring and summer. The art of getting rain from here to here is to wait until this flow, the west to east flow, collapses immediately subsequent to full moon. At that time, the primary energy translators, the apparatus at Hatfield Flat here in San Diego County, Desert Hot Springs, Banning, and on Point Furman, is all put into action to bring about a diversion to the northwest of this normal south to north current. The result is that instead of this normal flow of moisture going over into Arizona, you pull it 240 miles to the northwest and lay it into statistically rainless LA Civic Center in July. A man is given few such moments as I had, videotaping that lightning from my own operations deck on that unforgettable night during Pincer 2 in July of 1986.
Nothing impressed me as much about Pincer 2 as the record, the indelible record, of the National Weather Service radar facsimile maps, which showed that the rain had come into the Los Angeles basin exactly as predicted on our engineering drawing. Along the red route, first of all, in the afternoon and early evening, and then later that night, as you have seen, right up to Point Furman and beyond and up to Los Angeles. Let's take a look at the radar maps. The red route here into the Los Angeles basin. The green route here into the Los Angeles basin for the moisture from down here. Now here's the radar reality. National Weather Service facsimile map of radar echoes recorded at 3:30 p.m. on the afternoon of Tuesday, the 22nd of July, 1986. Here is the telltale story of rain on the red route from the Gulf here up to the Los Angeles basin. Here's our target zone right here, Los Angeles itself. Here is the red route being lined out for you with rain showers. By 4:30, it is getting to be a mess as this begins to drift over through the Banning Pass into the LA basin. By 5:30, the fix is really in, and the moisture is on its way massively into the target zone.
By 7:30 p.m., the pincer on the red route is into the Los Angeles basin and rain is falling. By 9:30 p.m., the green or coastal route is becoming active and rain is advancing on the target zone from the south in accordance with the pre-filed engineering drawing. By 11:30 p.m., these cells are becoming more and more intense and moving in a northerly direction. Half an hour after midnight, that is at 12:30 a.m. on the 23rd of July, the pincer is very evident there as the rain from the south moves east of Point Fermin onto the target zone. By 1:30 a.m., the pincer is closed from the green route. No doubt about it. By 2:30 a.m., the Los Angeles Civic Center rain gauge is covered right there. Still, at 3:30 a.m., the target zone and the environs are well covered, and a major statistical victory has been recorded.
When all the statistical dust had settled, Los Angeles had received its wettest July in 100 years. 72 out of 100 official observation stations in Southern California had recorded rain in July 1986. The way was open to more adventures in primary energy weather engineering, and a notable one between Pincer and today was rain engineering in the dry season in Singapore. Whoever thinks of Singapore as being a place that needs rain? They're right on the equator, 1 degree north, and they have over 80 inches of rainfall a year. Why would they need rain? Well, they have better than 2.5 million people on that small island, and they still have a 3-month dry season, a period of greatly diminished rainfall that the government has trouble bridging. Operation Tango was an experiment to establish the degree to which modern primary energy weather engineering methods could relieve this situation and change the dry season into a season where, with the use of these techniques, you could have just about all the rainfall you wanted all year round. I'll let the videotapes and the radar fax maps tell the story.
We will describe Tango with the aid of these meteorological service maps from Singapore, which have 50 kilometers between the rings. Singapore Island is the green area here at the tip of the Malay Peninsula. Here are the islands of Indonesia here, the Malacca Strait here. The center of our map here, where these axes intersect, is the Changi International Airport site of the radar installation. Our planned starting point is due south of Changi, and we proceed due west in a brewing pass, passing south of Singapore City, on over to where the red chip is, where we execute our Tango technique. This is intended to inflate and divert a disturbance already present from the previous night's operations northwest of Singapore and bring it over the scene like that. There's our route. At 10 a.m., there is the rain mass raised overnight by our operations. Let's watch it. By 11 a.m., the boat is now due south of Singapore City. and the rain mass has begun to swell in response to the westerly passage of the spinning translator on the boat. By noon, the boat is almost in position to begin the tango technique, and the rain mass has begun to really swell here and dominate the scene. The 9 km indication is that lightning was seen in this direction. By 1 p.m., the tango technique is complete. The rain mass has been grossly inflated and spun south of that east-west axis line. The front of that rain mass is now more than 200 kilometers across, and from the boat we'll give you a look at what 30,000 square kilometers of rain looks like close up. By 2 p.m., the island of Singapore and most of southern Malaysia has been simply engulfed by this rain mass. The system maintains its size and density on through 3 p.m. on the 26th of July. These are official maps. By 4 p.m., all of southern Malaysia is enveloped in this massive unforecast system. 50 kilometers between the rings, as we told you initially, and there you have 200 kilometers. The engineering of rain is always an exciting business. Thrilling, personally fulfilling, after learning to do it over a period of 20 years. There is always a concomitant benefit to rain engineering, and that is cleaning up the atmosphere. Special variants of these weather engineering devices were developed in 1987 that were incorporated in a project in July of 1987 exclusively intended to test these implosive vertically operating units. These are typical Apache type units used in Victor. The filing for Victor with the federal government called for an operational period 27 June through 05 August. And in the addendum, 2 particular items of anticipated effects are worth noting. Frequent and substantial reductions contra forecast of LA basin temperatures, and frequent generation of offshore Catalina eddy activity materially influencing both weather and forecasts. These 2 items were to come true in spades. In July of 1987, Southern California had its cleanest air in more than 30 years. Everybody concerned with smog, right down to the ordinary citizen that has to inhale it, was utterly astonished by the weather conditions that settled into the Los Angeles basin and stayed there throughout the month. The records are all there if you want to study them in terms of mathematics. What is more important in a presentation of this kind is to get something of the flavor of the chaos that reigned
in TV newsrooms amongst weathermen and others as the good weather went on and on in a month that traditionally produces terrible suffering for hundreds of thousands of Californians. Let's take a look at some of those highly informative clips that will tell you exactly what happened when our two translators went into action at Desert Hot Springs on the desert and out at San Pedro on the coast.
Rain that we had this morning, that was not rain. Give you another advantage to this weather. Air quality, beautiful, no pollution. Comes with the weather. Wait till next week. All right, now at 72 in 1926, we tied it for the coldest afternoon temperatures. My quality. Well, how about a first, second, or third stage? Not today, not with this.
Describe the weather we're having now. One word.
Wet. Gray.
Damp, gray, anemic.
There's a good word.
That's a good word for what happened today. Yes.
Kind of crummy. How about crummy?
Crummy. Now that's the word I was fishing for.
You really
Yeah, we've had drizzle out there. We have had a little bit of wind. We've been hearing thunder all around. At least that.
That's strange.
Yeah.
I heard that.
Yeah,
Hey,
she heard
hey.
that. Okay, that's two of us. That's an eyewitness. And again, we did not get any clearing today. The temperatures have not warmed up. It didn't cool off that much, and we've had drizzle and thunder showers out in the desert. So, indeed, it's good. The air quality is good in all areas and should remain so until we find summer again lurking around someplace out there.
Been seen in Southern California this century. We have a January cutoff low over us. The jet stream right now is coming in over Palos Verdes. Never happens in July. We've got wintertime weather, and let's get right on over here. This is supposedly a picture of the jet stream. Actually, it's just a flow pattern. It's my 500 millibar motivated. The jet pattern comes down like this. And now you can see it over here this way much better. This is the jet stream right down here underneath these clouds. Actually, this is a picture of humidity. It comes down like this, and here we are in Southern California. There's Palos Verdes. Well, it's actually going over Fountain Valley at the moment. That's the jet stream, and it curls around, and up here, there is the storm just south of Medford, Oregon at the moment. Now, what we expect this thing to do, instead of digging any further, it's still digging a little bit now, is that it'll start going around like this. That's low center, and even by next Wednesday, that should be out there. Now, this, we've seen pictures like this before. Look at the marine layer in there. You want to know something interesting about that marine layer? 7,000 feet thick today. 7,000. Normal for July is 1,500. That is so high that they had drizzle this morning on the top of Mount Wilson. You don't catch things like, and these, notice that pattern? That's a cloud pattern of cold weather, just like January.
Okay. Downtown looked great today. Visibility is not the problem, either is the air quality. However, we're 10 degrees below normal in the temperature department, a high of 73 and a low of 60.
Is when the absolute coldest temperature in California this morning was 23 degrees in Truckee, California.
That's cold.
Yeah, I checked the ski report,
July?
but nobody's open.
The California natives here, we can't recall it ever going this long into July with this bad of weather. It finally cleared up.
Up some rather high clouds in a lot of areas, especially in the San Gabriel Valley. Picked up some rain this afternoon. As you take a look at downtown Los Angeles about an hour or so ago from our Channel 2 weather cam, let me tell all you folks in Riverside that you broke a record today. Yeah, your high temperature was only 74, and you have always been warmer than that on the 20th of July. So
quarter of an inch, Westwood 1/1500th of an inch.
Anything would be a record because we've never had any, have we?
It's incredible, and not for many, many years. 9 degrees below normal for this time. It's like February weather.
All right, let's show them what the air quality is. It is good in all areas. As the temperatures start warming up, we will get back up to first stage, but it's nice out there, so go out and breathe early and often.
Yeah, there are people who complain saying that it's too cold. These are the people who work in air-conditioned offices all day and come home to an air-conditioned house at night. But there are a lot of people who don't have either, and boy, they appreciate it. Quality, delightful, oh boy, it certainly is, all up and down.
You ask? Well, he answered with mostly good, moderate out in the valley areas, but nothing like first or second stage smog alerts. And
Be flirting with first stage alerts though in the San Gabriel Valley and also out of Riverside. So we've had really super air quality here in Los Angeles for this summer. But you know,
well, the experts had to leave. We didn't have enough smog.
That's right. They were here this week and they said we have no smog to study, so we'll go home. I don't know.
Air quality, dandy. All right, you can't say any more about that. Jerry had a story earlier about people who came out here to study smog this summer. Didn't find any. Now, yes.
Those people who came to Southern California in that memorable summer of 1987 were scientists. 200 of them were brought here by the Air Resources Board from all over America and from many overseas countries as well. These scientists were organized into some 50 teams and strategically sited throughout Southern California for the most ambitious smog study project in history. Unfortunately for that official project, our Operation Victor, a pilot project, started at the same time, and by the end of the third week in July, the air in Southern California was so clean that it deprived the visiting scientists of the statistical opportunity to gather valid samples. And so they were sent home without malefic intent. I repeat, without malefic intent. Our project, with a $5,000 budget, had put out of action the State Air Resources Board project, which finished up costing the California taxpayer more than $10 million. You see, after Project Victor finished its main phase in August, the smog became terrible again, and they brought the scientists back. So the final bill was over $10 million. Suddenly getting the cleanest air in 30 years sort of threw a monkey wrench into the smog bureaucracy and its ways of thinking and doing things. The whole happening was palmed off as a meteorological fluke. That's the way that it went into the records, a meteorological fluke. And you would not be a person of common sense if you didn't say, Constable, you just got lucky in 1987. It was a meteorological fluke. And what happened in 1988? A good question. In 1988, we did nothing in Southern California, nothing at all. And they racked up the second worst smog season in the entire decade of the 1980s. Now that is correlation number 2. 1989, we entered the smog wars again with a special nexus of events surrounding the whole happening. Pursuant to that terrible smog year of 1988, the smog bureaucracy had drawn up a battery of draconian restrictions that they are now in the process of imposing on Southern California people, business, and industry. So that's the format in which we filed Operation Breakthrough in July of 1989 and Operation Checker to run through September and October during the 1989 smog season. In a reprise, with a great improvement, the phantoms of 1987 rose again as Southern California experienced its all-time record low year for smog in 1989, with us operating for 3 of the 6 months. Those are the statistical facts, and they are a matter of record. On Friday, 3 November 1989, right after the official number crunchers had finished with the 1989 smog statistics, Maria Cohn of the Orange County Register wrote this story about just how good things were in Los Angeles in 1989. The smog season ended, she said, with Southern California residents breathing the cleanest air in at least 40 years. And over on that right-hand column, you'll see an account of how much better things were in all the traditionally smog-laden communities. To wrap it up, Maria Cohn cites Joe Casmassi, chief meteorologist for the smog people, who simply calls it the best year we've ever seen. There you have 3 correlations between our activities and the state of Southern California smog. Would you like to try for 4? Here for the record is the official federal filing for Operation Clincher. Note that the purpose of the project or activity on this government form is laid out there. Record seasonal reduction of smog 1990, Southern California. There are the dates on the federal form. Preparatory in April, official start May 1, and termination will be on the 31st of October 1990, the full smog season. Filed in advance as required by law on the 6th of April 1990 and signed by yours truly. No saying that we did it after the event. So that is the status in 1990. We're moving on now through June as this is recorded, and you are going to be able to judge for yourself whether or not Clincher clinches the question of our influence. And this is an historic operation in more ways than one. Should Clincher succeed in the fashion that I fully expect, Southern California is going to have the type of air, the quality of air, that it expects to have by the year 2000 if everything goes well, using orthodox methods and God knows how many billions of dollars. You can have it right now in 1990. This is all being done, ladies and gentlemen, with an environmentally pure method that doesn't put any electromagnetic radiation into the atmosphere or use chemicals in any form whatsoever. It is environmentally pure. Furthermore, people don't have to worry about being harassed and hectored and hampered by regulations and rules. There is another way to clean up this air, and it's here now. You do not have to wait until you are old and bent and broken for that. We fully expect that Southern California business and industry will support and sustain the Atmos Group in cleansing the Southern California environment. If that does not happen, the Atmos Group will participate no further in cleaning the Southern California air. There will be no more clean air from us for free. Wherever you are when you see this tape, you're involved in the whole question of air pollution. Because if we don't clean it up by a method like this, you are going to be one of those who pays to try and clean it up by bankrupt, out-of-date methods. Please, ladies and gentlemen, remember our credo. Only results count. Let's give these methods a real chance to help mankind. It is now November of 1990. Operation Clincher is history. Time for an epilogue. Let's take a few minutes now and review just what happened to all those grandiose expectations recorded on this same tape back in June of 1990. Let's see what happened in the real world. Where else to find out the facts but in that bastion of truth and accuracy, the Los Angeles Times. There it is, the 1st of November 1990, and the smog season for 1990 is over. Time for the Times to tell us what happened. The cleanest air on record. Boy, how we worked for those few words. Marla Cohn in her article tells it all. The cleanest air on record. Now, Joe Casmassy, the senior meteorologist for the smog people, calls it mind-boggling. It's like night and day, he says. There's been a dramatic improvement. He was told before we started. There it is, a 24% reduction in the number of alert days. Even more important, a 60% decline in the duration of the alerts. Never has such inroads been made on smog. Never. The men who worked with me in putting Clincher together and making it a success were especially gratified by the regional health benefits. Smog physician Phelan says that everybody living in the region had a health benefit from the reduced smog. Now that rapid overview provided by the Los Angeles Times gives you a good idea of what happened in a sketchy way. To sum up, in 1990, Southern California smog took the worst knock that it ever has since the smog records were instituted. The term alert days, by which each smog season is compared with other smog seasons, is basically a statistical abstraction. Certainly, we won the alert days battle, but the bigger victory lay in the real-world happenings, things that are actually quantified. Let's take a look now at a list of the number of actual alerts in the various districts. This list was published also by the Los Angeles Times. Let's take a look at it because it's very enlightening as to what really happened. The red handwritten figures give the percentage reduction under 1989. Ladies and gentlemen, those are tremendous drops in the actual numbers of smog alerts. A lot of those communities previously troubled had 100% drops. Many of them were 0 alerts for the whole season. San Bernardino down 68%, a real trouble spot. And now we have a graph of our 3 interventions in Southern California smog. 3 years, 1987, 89, and 90, with a stand-down control year in 1988. Now let's take a look at this. Smog season years across the bottom, and the vertical axis is alert days per season. Starting in 1986, there was a drop, a record drop to an all-time low, our Operation Victor. The following year, 1988, when we got right out, there was a rise back to a more or less normal smog level, followed by a drop.
in 1989. 2 projects, 3 months, almost a 30% drop. And this was followed in 1990 by an almost incredible further 24% drop to the all-time record low there. There is the totality of our intervention, a signature. Ladies and gentlemen, by the end of the smog season in 1991, which will be here before we know it, the smog bureaucracy will have good factual cause to regret ever having tried to claim credit for the 1990 victory over smog in all its comprehensive completeness. You see, in 1991, the Atmos Group stays out. We will not participate in Southern California smog in 1991. The smog bureaucracy and those tough regulations that they presently attribute the victory to are going to have a clear field. Furthermore, they have walked into a sort of trap of their own making. There will be more regulations in force by the time the smog season opens in 1991. More regulations. That means that if the regulations are doing it, they have no excuse for not bringing about a further reduction in smog next year. We'll see. We'll see who's right.
This is the Black Widow, a basic projector of etheric force consisting of a PVC tube with associated lined cone. There is another version of it. The cone and the tube are geometrically related to each other. All of these devices are basically projectors of etheric force. Even a simple cone like this is a projector of etheric force. These bazookas do not use cones, but employ layering. There is no electromagnetic radiation, no chemicals, no external energy source. This is the termite. We call it that because as the ship moves and this rotates, it literally bores into the ether, setting up etheric vortices. You're going to see these. Termites come in different sizes. This is a termite 135. Also a vortex generator. This is a small one, about the size of a coffee cup, the 4x4. This is the Box Apache, a basic and simple generator of vertical etheric vortices. Such an arrangement stirs vertical ether currents into vortices, and these translate into rain. This is the brainchild of Irwin Trent, my oldest and closest associate. We call it the skimmer. It's simpler than the simplest transistor radio, but it will make rain in high pressure. You'll see this. Here are a couple of skimmers in a spider-type arrangement. This also raises hob in the atmosphere. No chemicals, no electricity, ever.
Some of them are pretty small, as you can see from my hand. We call this one the Matterhorn. There's a couple of very precisely tuned chambers there, but once again, no chemicals and no electricity, just the power required to rotate this thing. This is a Mark X spider. It is an effective generator of etheric vortices, and it is perfectly capable of surrounding a moving ship with rain even when the barometer is high. There are many variants of the spider. Here is a Mark II spider, working, believe it or not, 6 decks down inside the Maui's hull and below the waterline. If you happen to be a physics professor, this is going to boggle your mind. Here is a similar spider working on the flying bridge in the horizontal mode. With these devices, the idea is to cater to the ether's tendency to move in the form of vortices. There are dozens of variants for generating these vortices, and they are all descended from the original devices, the projectors, that we're going to show you first.
In the earlier teachings of Dr. Rudolf Steiner, this energy form is called the chemical ether. Dr. Reich demonstrated the existence of this orgone energy, or primary energy, or chemical ether, visually with the orgonoscope, an instrument that he designed, thermically with calibrated thermometers, with the electroscope, and with the Geiger-Müller counter. That was all done in his lifetime. In more recent years, Dr. Walter Stark, a Swiss physicist, developed a special device, a digital instrument called the orgonotester, that provides a continuous digital readout of the activity of this free primary energy.
When the responding ether locks itself into a pattern that is due to the equipment upon the traveling ship, that pattern of gross meteorological effects occurs regardless of the existing surface weather. The best aid we have in establishing that this happens is, of course, radar. Let's take a look at an example of this kind of thing. This is a photograph of the collision avoidance system of the SS Maui, taken on the 30th of April, '89. Now, the collision avoidance system gets its information from the Maui's radar. So everything you see here has been derived from the Maui's 3-centimeter radar. This red dot here, which I have stuck on the photograph, that represents the Maui. That's her at the center of the screen, that red chip. This dotted line here is her course line from Honolulu to San Francisco. This circle represents the ocean area around the Maui with a radius of 24 miles. So this circle actually has a diameter of 48 miles. An important clue here to what is going on is this sea clutter out in this direction from the Maui. That is caused by the vessel's headwind coming in on this bearing. Any experienced deck officer in the merchant marine, any experienced naval officer will tell you that this sea clutter gives you a clue to the existence of about a 20-knot wind coming in this direction. So the Maui actually has a good stiff breeze going this way and she is herself going this way at 20 knots or better. Look at this rain formation here extending up here like this at right angles to our course. A considerable amount of moisture. Millions and millions of tons of water are coming down out of this as we go. But we did not leave this barrier behind. We towed this barrier with us across the Pacific for at least 80 miles that evening before it began to dissipate after midnight, when there is a definite change in the etheric forces going on. This is typical of the practical, objective guidance given to our work at sea through the modern miracle of radar. Radar does not lie. These official ship's thermometers show us that we have a 1 degree differential between the wet and dry bulb readings, and that therefore the local atmosphere is not saturated. And over on the barometer, 1021 millibars. And over here, to the south and the southwest, high pressure or no high pressure, you have rain, and plenty of it. I wonder how it came about. Here is the culprit, set squarely against the background of his effects. Rotating at approximately 2 RPM and aided by a similar termite on the other side of the ship. We're in the perpendicular mode. We are eastbound. We've just come out of Honolulu. There is a lot of moisture in the air, and our geometric guns are in the perpendicular mode. We get a very rapid brew-up. Massive and vivid. The whole scene is transformed right before our eyes. And there you have it. All the way up to rain in that shorter length of time. Engineering. You saw it all happen right from zero. From this all the way to that. The devices that we are using on these aircraft are the simplest technological devices in the world today. There is nothing simpler. We are dealing with an empty, hollow tube with a mirror at one end. That's it. But you have to know how to shape the tube, how to tune it, and how to use it. Now let's see it all in the real world. Greetings. I'm very glad to be here and have this opportunity to discuss with you a development of considerable value, not only to this country but also to all mankind. I'm referring, of course, to the development of etheric rain engineering, and in particular to its ultimate development where it is carried on aircraft, either on helicopters or on light aircraft. This is a considerable advance in weather modification, which up until now has been an entirely chemical process and not too successful. Anyway, the beginning of this and goes back to some experiments that I carried out while I was an officer in the United States Merchant Marine. And I was assigned to the Matson flagship, which at that time was the SS Maui, brand new out of the yard in Bath, Maine. In the course of the next 13 years, I carried out thousands, literally thousands of experiments in controlling and engineering rain from this speeding ship. And this was all comprehensively documented on videotape. This type of desire to interfere with Mother Nature's normal routine goes back just about as far as written records take us. There are records of rainmakers in ancient Egypt, and here in the United States we have had rainmakers in Hawaii, the old kahunas, the ancient kahunas, who were repositories of considerable wisdom regarding the energies involved, and also some of the Seminole tribes in Florida have had this capability of modifying the weather, mainly by engineering rain. It's not something that is completely novel and new. My engagement and involvement with all this goes back a long, long way, back into the 1970s, when I was doing this out on the high desert of Southern California, utilizing very large, ponderous equipment. And then later on, when I went to the United States Merchant Marine as a radio electronics officer, I was able to do this on the high seas, on shipboard, where I had a pristine environment and none of the problems that were attendant upon operating in the desert. During this period, I became familiar with the work of the late Dr. Wilhelm Reich, a distinguished physician whose life was surrounded in controversy and who died in a federal prison in the United States and had his books and experimental bulletins burned by federal court order. This is a very eminent medical doctor, educated at the University of Vienna, who was, during his initial work in psychoanalysis, the first clinical assistant to the eminent Dr. Sigmund Freud. Dr. Reich focused his clinical work on the enormous convulsive energies that manifested in patients at certain phases of their therapy. He could not believe that ordinary people could be going through this type of convulsive activity unless there was some kind of energy driving the entire process. His focus on the energy that was causing the convulsions led him, after a long and involved attack on the problem, to establish that there was a specific biological energy. This involved many years of work to isolate this concept and then establish it as a clinical fact. He called this energy orgone, O-R-G-O-N-E. And in that way he identified it, first of all, with things organic, and secondly, with the human orgasm, which was really the root of his original research. That was the thing to which he devoted his life. And he established, after considerable labors and devoted effort, that the orgone energy was a real physical energy, and that you could indeed manipulate this energy in the atmosphere. And he found this out in the most strange circumstance imaginable. In Maine, where he had his laboratory, there was a nearby lake, a very large lake, and he observed that there was what we call heat waves going above the surface of the lake in the summertime. That is what we would call them in a general way today. Most people would say heat waves. He said, now wait a minute, this isn't quite right. There is a certain order to the way they move. They move from west to east. They don't move in any other direction. There's a directional component to this. And while he was making observations of this kind, systematically and over a period, he happened one day to step into a depression in the ground there at the laboratory where some construction was going on. And there was a mass of pipes that were being cut for installation in this depression in the ground, and they were in water because this was an ongoing construction project. And when he stepped on one of these pipes, he noticed that the energy that was going across the surface of the lake jumped like that. And so he tried it again, and he pressed the pipe down into the water, and the energy jumped again. He found that he could do this almost like pushing a button. And that is how he discovered the link between the atmospheric orgone energy and the means of developing it. That is to say, pipes. Pipes with one end grounded in water. That is the origin of the device that he invented and gave to the world, and which has been extensively used since, even if not officially approved. It's not politically correct, let's put it that way. And he gradually developed a system of operating multiple pipes with a special grounding system into running water. And he found that he could interdict and back up this west-east flow that he observed over the surface of the lake. And thereby, the basis for controlling the weather was laid, in a sense, by a series of fortuitous accidents, as so many great discoveries have their origin. That was the way it was with the discovery of the orgone energy. So I inherited it pretty much in the way that Dr. Reich left it when he died in a federal prison in 1957 and had all his books and papers burned, so that none of the bright people who are around today would have any access to information of that kind. It's very, very powerful and important information. And this droughted world that we inhabit at the present time could normally have that condition substantially mitigated were these methods employed, were they introduced on a general basis. That much can, could, and should be done. However, intervening to preclude all this happening are the political factors involved, political and financial factors. Wherever there is a drought, there are anti-drought measures being enacted and enforced. Almost any government anywhere in the world that has a drought at least tries to do something about that. Even if it's hiring water trucks to go around and cart water to the houses, deliver water from the trucks to the poor suffering people. That much a government must do. They have to do that. But if you hire a water trucking outfit to do this, and you have maybe 300 water trucks at $400 or $500 a day each, you immediately have a big contract involved with all this. And this invariably happens in any part of the world where there's a drought. That's one of the things that makes it difficult to get all new methods like those I've developed into full general use. It's a thorny and, unfortunately, a well-nigh universal situation. Needless to say, attendant upon this entire situation is the question that the people who get government contracts for anti-drought measures see fit to bribe the politicians who are in authority and keep the entire game going that way. That's how it works. And I would hope that within the next 10 years or so, more of that can be done away with and the entire drought situation rectified all over the world, especially if we further develop these methods and these instruments so that we can bring the water down directly from the cosmic expanse overhead in its pure form wherever we want it. We don't have to duct it around or put it into waterworks or anything like that. We just bring it down. It's a primal dream of mine ever since I started in this field was to tap the cosmic expanse. After all, you might say that God Almighty has stored hundreds of billions of tons of water up there, and all you've got to do is be smart enough to obey the necessary natural laws involved, and you can get it down and use it. Now, all this has a tendency to strain credulity, to put it mildly. that you can, without the use of chemicals or electric power or any other mechanical agency, engineer rain literally anywhere you want it, outside of the world's deserts, which we have yet to conquer and where we do not accept any engagements. It does strain credulity that these things can be done. However, videotape does provide us with the means by which we can bring these wonders directly to you in assimilable and comprehensible form so that you can see exactly how it is done. And I'd like to say, as a prelude to this, that the devices that we are using on these aircraft are the simplest technological devices in the world today. There is nothing simpler. We are dealing with an empty, hollow tube with a mirror at one end. That's it. But you have to know how to shape the tube, how to tune it, and how to use it. Now let's see it all in the real world.
Yes, rain will result, and you are going to see this happen from zero dynamically. Our 23-knot ship is heading east. The ship is east of Honolulu, Hawaii. A gorgeous tropical day. The magical power of time-lapse compresses the events of 3/4 of an hour into a few seconds. As we watch, our high-pressure, non-rain day is transformed before our eyes into a dismal day, and rain is imminent. We do this now with light aircraft or helicopters. The entire thing is new and revolutionary, but it is, after all, the same old rain.
Hello. My name is Trevor James Constable. I'm the engineer that staged and carried out the rain engineering experiment that you just saw. Engineering rain off a clear horizon right over a speeding ship. That's something I've done literally hundreds of times. But always I dreamed of doing the same thing from an aircraft. Trouble was, the apparatus that we were using at sea was a little too big. Much, much too big to be hung on a light aircraft. When, through research and experiment, we got the size down and the power up, then, and only then, could we go airborne. Ladies and gentlemen, we are involved here in something that is intensely realistic. We utilize hardware, things like aircraft, things that are right down in the real physical world. There's nothing ghostly about any of this. Let's go now to the island of Oahu in Hawaii and involve ourselves directly in a real-world operation of a completely new kind, an airborne etheric rain engineering operation. Let's go.
This is the Hawaiian Island Group in the Central Pacific. Our base is on the island of Oahu, illuminated for us here by our laser dot. And this is Oahu close up. For orientation purposes, there is Honolulu, the main city. And just to the northwest of there is the famous Pearl Harbor. And in the far northwest is Dillingham Field, our operations base. The main topographical feature of the island is the Ko'olau Range. This is a rocky spine running the whole length of the island. The Waianae Range runs over south of Dillingham Field, south and southeast. The operational plan is very simple. The airplane takes off from Dillingham Field and flies due east at 70 miles an hour for no more than 20 minutes. The aircraft then turns away and goes back to its base. That is the extent of the aircraft's involvement.
All right. That's the operational procedure. Nothing too difficult about that. The question is, how is it that a single small aeroplane with a single small piece of hardware aboard can generate rain under such circumstances? How is it possible? The reason that this works is that the translator on the aircraft accesses not the air, the atmosphere, but the ether. It accesses the ether and it pushes it backwards. Now, since the ether is invisible and basically intangible, in order to get an idea of how this works, we are going to have to use some transparent plastic like this to simulate the ether in the sketch we're going to give you now, so that you'll understand how this is done, what the process actually does bring about in the real world. Here we go. There is the ether coming from east to west, right across Oahu and right around the Earth in tropical latitudes. Irresistible, invisible, eternal. The airplane enters the format at Dillingham Field with translators so designed that they interrupt and push backwards locally this flow of etheric force in the fashion depicted. The airplane leaves the format and it leaves behind an accretion of etheric force right there, which draws to itself enormous masses of water vapor from the atmosphere. With the aircraft gone, this mass of water vapor, rain, moves over Oahu, and you have engineered rain on the island. To make things perfectly clear, the red chip designates the target zone in our operation, and offshore, that blue area there, that is where we should expect to see, perhaps, a satellite from thousands of miles up pick up a plume of moisture that we're going to generate with the aeroplane. Well, that's enough theorizing. Let's go right out now into the real world, but before we do, let's get a solid, objective weather forecast for the day from Honolulu TV. And they're going to tell us that picnic weather is going to prevail over Oahu. Here it is.
Lovely. Just wanted to show off. We have some clear skies for you this week. That's nice to see after looking at last week's forecast. Let's get a close look at this. Our surf is pretty much getting nothing. It's 2 to 4 in the north. That's your highest surf points. Also the east 2 to 4. But you look around, there's nothing to do. There's not even a high surf advisory. There's no gale warnings, nothing happening. And if you want to probably go snorkeling or just wind sailing, something mild, the picnic, that's where you go to the beach. And the weather's a good forecast for a picnic as well. As you see, a mostly sunny day. And our temperatures will be comfy in the mid-80s, southeasterly winds 5 to 15 miles per hour.
The plane is airborne at 1:15 p.m. The aircraft will make a single thrust due east for a period of 20 minutes. At 1:52, the plane is back from its mission, the pilot coming in for a debriefing. He reports rain around Waialua and over towards Haleiwa. It has pleased him. And at 2:16, beyond the runway over towards Haleiwa, we see it is indeed raining, and it is time to get a bird's eye view of what's going on. Now, the best way to get a bird's eye view of what's happening here is to act like a bird. Get aboard a sailplane. Up we go. Heading east. The tow plane in front of us. And there's nothing like getting a few hundred feet of altitude to see what's going on. There, to the magnetic east direction, is rain. This was induced by the thrust of the aircraft. As the tow plane curves us in a climbing turn, we get an opportunity to run a nice panoramic shot of central Oahu. As we continue our climbing turn, we are now heading to the west, and you can see the remains of that nice day underneath this blanket of rain-bearing cloud. With the tow plane gone, we're heading back now towards central Oahu, and we're looking at central Oahu over the top of the foothills of the Waianae Range, facing approximately southeast at the moment, and that is socked in. That area is being heavily rained. I would say at the rate of about an inch an hour, based on past experience. We're at 3,000 feet or thereabouts at the moment, and we're starting to get rain up here, and the pilot has indicated that we will very soon have to terminate this. But our altitude gives us unequivocal evidence of rain engineered into central Oahu. No two ways about it. Now it's beginning to close in on us, and we're in it. Yeah, that's right. I won't charge you for the watch, Bill. Remember today's television weather forecast? Picnic weather. Well, rain came down at the rate of an inch an hour for about 2.5 hours in central Oahu this afternoon, and led to a small stream and flash flood advisory. So they did indeed have picnic weather in central Oahu, but it was a different kind of a picnic.
Has been very, very wet this afternoon. In fact, the National Weather Service has issued a urban and small stream flood advisory. That's for the areas from about Wahiawa up to Haleiwa. Heavy showers have been coming down here. It's convective activity. Things are a little unstable out there. So when things heated up, that set off a series of fairly good showers out here, mainly in the Po'omoho and Haleiwa area, and the urban and small stream is in effect until 8 o'clock tonight. Could be some ponding in roads out there, make driving a bit treacherous, so be careful if you're heading out to that direction.
And small stream flood advisory is now in effect for central Oahu from Wahiawa all the way up to Haleiwa. There we go. And here's the shower area right here under that flood advisory. It is in effect until 8 o'clock tonight. It looks like most of that moisture will end after sunset. All the shower activity coming from a separate area of moisture. Not right now. I'll show you here on our satellite loop, which represents 12 hours. You can see the little plumes develop there. Here's the moisture that's affecting Haleiwa area being hardest hit the past few hours. It's been raining so hard that the smaller streams are at the point of almost overflowing. But once again, you can see the little plumes develop.
Now she is showing you our little plume that we created with the aeroplane. She'll put her finger right on it.
Develop there. Here's the moisture that's affecting Haleiwa area being hardest hit the past few hours.
Now she's got her finger right on it, and it is directly to the east of Oahu. In other words, it's right in the zone that we disturb in accordance with the diagrams that I showed you earlier on. That's just about as elegant a demonstration of how it works as one could possibly wish for. Well, that's how it's done in Hawaii, on the fringe of the tropics, where all this was pioneered. Now, deep in Equatoria, down in Malaysia, the Philippines, and places like that, these processes work with much greater effectiveness and power. In October of 1997, we ran an interesting little operation out of Segamat in the center of Malaysia. Let's take a look at that. Takeoff from the Segamat Country Club is at 2:31 p.m. Our mission is a single 15-minute flight directly to the east right off the runway, to be followed by a second such operation, provided the weather does not become violent. The weather's response to our thrust is sharp and nasty, putting the follow-up flight in jeopardy. Our number 2 flight was indeed curtailed, limited to 9 minutes by imminent, very heavy weather. With the plane back now at 4:43, we'll have an interview with Captain Bala Ratnam, our pilot, and he'll tell us professionally exactly what he's just seen.
We have a large build-up over there.
Yeah.
Over there, and there's one more which is coming down from the south, which is right now building about 15 miles away. And she's coming in fast because we are having prevailing winds coming in from this direction.
Yeah.
So she will be along here quite soon, and the build-up over here will be here approximately in about 8 minutes' time. So we can see both masses joining together and giving us a very heavy downpour.
Good. Thank you, Bala.
No problem, sir. Anytime. Anytime.
10 o'clock on the night of the 14th of October. We're looking out now from the hotel, from the 7th floor of the Villa Hotel in Sagamat. And this entire area is now being enveloped in rain, thunder and lightning. This is the consequence of the operation today. And we'll go down to street level and let you see this happening. Outside McDonald's, the main drag, it's a wet night, courtesy of the men from Singapore. Welcome rain soaked into an area that had been dry for months and was very welcome. The rain persisted through until 2 the next morning and laid down between 2 and 2.5 inches over the entire region. Our pilot in Malaysia is a Singaporean named Captain Bala Ratnam. He is of Indian descent, and he was trained as a pilot in the United States. When we first attached this hollow tube, this empty tube with no electrical connections and no chemicals, to the wing strut of his Skyhawk, I saw him smirking a little. After he had flown 10 or 12 of these weather engineering missions and had made his share of the world's rain, he had different ideas. I was able to capture some of his comments on videotape. Here is Captain Bala Ratnam. Like a normal person, you no doubt had your skepticism about the whole thing. Is that correct?
Very true. Never thought it would work. Never did. And because basically there was what I know about cloud seeding and causing rain. Basically use some kind of chemicals, smoke, something to make the cloud more dense so that it will basically rain. And having 2 tubes in my airplane wasn't much of a, how shall I say, it wasn't really acceptable. It doesn't seem workable in that manner.
I see. And what's your view now after several weeks doing this?
Dangerous thing. Never had the tubes on your wings. The results have fascinated me to a very great extent. Never did I expect flying on clear days to have experienced such turbulent weather within such a short period of time, and it appearing without any notice whatsoever.
Yeah, I see. You have an FAA license. You were trained in the States, right?
Yes, I was, and I hold a commercial multi-engine instrument rating license with an instructor on single engine and also on instrument rating.
I see.
And my license number is 2466946.
Okay. What is the thing that has occurred in these flights that has impressed you most with this new method of weather engineering?
Okay, number one, simplicity. There's nothing to be thrown out, nothing to be dispersed in the air, and it's very efficient. It's very efficient.
And you're convinced of the effects?
Yes, I am.
That comes from first hand.
Having to dodge weathers, having lightning strikes, appear all of a sudden, left and right of you. Yes, it's first hand.
Kuala Lumpur is the capital of Malaysia. And the Kuala Lumpur city and region was in a severe 4.5 months drought when I was called as a consultant down there in April of 1998. The first thing I did was load some of our weather guns into a sky van, a twin turboprop transport. A big, strong aircraft, and it will carry anything we want to put in it. Made in the UK, essentially it's a flying truck. "28 hours after I set foot in Malaysia, this was the scenario at Subang International Airport in Kuala Lumpur.
In the week that followed that spectacular drought-breaking job, helicopters were put into service in this type of work for the very first time. Their use was pioneered in Malaysia in 1998. They proved themselves to be the most effective vehicle yet for engineering rain in the tropics.
Attaching the P-guns to the helicopter skids proved to be no problem at all. A solid, secure mount was very easy to make. Getting it approved by the bureaucracy was tough, but we made it. Helicopters take you easily into places that you probably shouldn't go. Here we're up above the Seminyi Dam in a squall. Downdrafts, updrafts, violent weather. Not a good place to be. We put a lot of water in this place, but it didn't seem to show on the dipstick. More a job for Errol Flynn. Heavy ponding in the heights of the Seminyi Dam. Heading westward at the conclusion of operations each evening, we would find that we were causing a west-to-east flow of ether to compress and swing to the south so that it arrived on our port side. You're looking at that now. And this engineered rain walks along with the helicopter, completely in phase with it, drenching the terrain below as we move. In this case, you're looking at about 12 to 14 square miles that is under rain as a result of the passage of the helicopter, just like crop dusting with water. Kuala Lumpur under rain. And as we come in for a landing at Subang International Airport, this whole area is still under rain and it's pretty well drenched. Getting back to the hotel was kind of wild. And back at the Renaissance Hotel, they are enjoying the first decent rains in 4 months. This is what I call engineering. And by night, the story was just about the same. And here is the world-famous KL Tower, wreathed in rain and cloud. That's the way it was in Malaysia.
This is a brief overview of the stunning potential of airborne etheric rain engineering in Equatoria. These are techniques and a technology that is available right now. It does not matter, ladies and gentlemen, what academic people say about the ether. I prefer the driving beat of rain on the canopy of my aircraft, because in the final analysis, only results count. Only results count. Goodbye. The devices that we are using on these aircraft are
the simplest technological devices in the world today. There is nothing simpler. We are dealing with an empty, hollow tube with a mirror at one end. That's it. But you have to know how to shape the tube, how to tune it, and how to use it. Now let's see it all in the real world.